Hello, everyone. Thank you for being here. Thank you for joining me. I hope you're all having a good morning so far. My name is Eli Phillips, and I am a sales lead, product enthusiast, all kinds of different things at Joy Labs, the company that makes Makey Makey. And today we are going to be talking about bringing invention into the classroom with Makey Makey. So I'm really excited to be talking about that with you. If you've never used a Makey Makey before, this is going to be a good introduction to that. If you've never used it with Scratch before, this is going to be a great introduction for that. So I'm really excited to be covering this topic with you. I'm going to show you what the Makey Makey is, how it works, how we can use these things together in the classroom, and then we have time at the end for some questions if you have any of those. So to get started, once again, I think we have a slide that's just me and who I am. I have been with Makey Makey for a few years now, and before that, I've been using Makey Makey for over a decade. And actually, we're running another workshop. Our company is right now with teachers, and I started counting it up when I was talking to them. It would have been in 2014, I think. So over a decade ago, I led my first professional development in a classroom on Makey Makey, and it was Makey Makey and Scratch. I had actually never run a STEM professional development before, and I got dropped into a process of using Scratch and Makey Makey together, and it was my first time using both of them. So I got to learn how to use those, develop some training on them, and then go into a third grade classroom and use the two things together, which was really, really cool. They have been I tell people all the time that they are my two favorite hardware and software products to use in the classroom with kids because they're both like so open and so creative and so easy to use. So this is a really, really fun thing for me to get to talk about. So like I said, what we're going to be doing today is I'm going to give you an introduction to the Makey Makey in case you've never encountered our product out in the wild before. So you're going to see what it is, how does it work, and what is it used for. Then we'll look at how that connects to Scratch. This is actually a really, really easy thing to do, but we're going to look at what it takes to connect Makey Makey to Scratch. And then we're going to talk about some easy project ideas to get started using the two of them together. And then lastly, a lot of people even who know about Makey Makey don't know about all of the things that are new with Scratch. And so we'll talk about those, and we'll talk about how we can connect those into the ecosystem as well. So this should be really fun, and I hope you're all as excited as I am. So like I said, to get started, let's meet the Makey Makey. Makey Makey is like it says here, it's a fun, beginner-friendly invention kit for turning everyday objects like bananas or Play-Doh into touchpads. I'm going to show you one right here up close. So this is the Makey Makey. You can see it on the screen there as well. But the Makey Makey, when I say those words, I'm just talking about this circuit board right here. And it connects to our computer, and then it connects to other things and turns those things into buttons on the computer, which can be a little bit weird, but we'll talk about the uses for that as we go. The important thing to know here is that it's really simple to use, it's really fun to use, and can be used in a lot of different ways. So the way that it works is you plug the Makey Makey into your computer, and then there are touchpads on the Makey Makey. So in this animation, what you can see is there's an alligator clip connected to a touchpad at the bottom, that's Earth. And if you were using a Makey Makey for the first time, what you would do is you could grab Earth, and then you could touch any of the other touchpads, and it's going to work exactly like a game controller. So you've got up, down, left, right. You've got the space button and the click of your mouse. And you can see what's happening in the animation there is that every time that alligator clip that is connected to Earth touches the left arrow key or the space key, the computer just thinks that we're touching the keyboard. Once you plug the Makey Makey in, it just thinks that it's a keyboard. And so we're able to interact with anything that uses the keyboard to make stuff happen. So once we've done that, we don't have to just use the alligator clips. Any conductive item or any conductive material can be connected to the Makey Makey to trigger a key press. So in that last picture we saw fruit. I think we saw definitely bananas, and maybe there was a kiwi in there. I've done oranges, I've done apples. Pretty much any type of fruit or vegetable is going to work, with the exception of sometimes you buy stuff from the grocery store and it has a wax on it that was put on it before it was shipped to the grocery, just to keep it fresh. Anything that you would peel might have a wax on it, and sometimes that will act as a barrier. But generally, any piece of produce that you buy is going to work. Metal works. All metal is conductive. So, utensils like forks and spoons and knives, those can all become buttons for your computer keyboard. Even something like a cup of water. If I take that alligator clip and I dip it into water, and then I take another alligator clip that's connected to the Makey Makey and I dip that into the water, or if I hold it and touch my finger into the water, that is conductive. And since I mentioned me being able to hold it and do it, all of our friends and loved ones, we are all generally conductive. What's happening there is that the conductivity is running through like the surface moisture on your skin. So if I held one alligator clip connected to the Makey Makey and you held another alligator clip connected to the Makey Makey, and then we high-fived, it would trigger a key press, just like what you're seeing on the screen there, and it could go through us. And we've actually done that with up to, I want to say 350 people, I think is the number that we generally say that we've done. I wasn't there when that test was done. But yeah, everyone just holding hands, and then like when the last two people connect, it would trigger the key press, and that's super, super fun. So how does all of that work? How does the Makey Makey actually convert fruit and utensils and different things into key presses on our keyboard? So what the Makey Makey does is it acts like a keyboard and mouse on your computer. So when you plug it in, the computer just thinks that you are connecting a keyboard and mouse. It connects over USB just like a regular keyboard would. And I've never run into a computer that I couldn't hook it up to and it just work, because it thinks it's a keyboard. So literally, when I plug it into my Mac, every time you plug a keyboard into a Mac computer, it's like, hey, this isn't an Apple keyboard and we don't recognize it, so tell us a little bit about it. And I just say, no, don't worry about it. There's like a little X, and I just click on that. I'm like, trust me, it's a keyboard, you're fine. Even though it's not a keyboard, it's this weird little circuit board. But all the computers I've plugged it into, they just think it's a keyboard. It connects over USB, and then it behaves like the keyboard. And all of those key presses on the Makey Makey behave exactly like you would expect them to in pretty much any application. So like I said, up, down, left, right, space, and click are all going to behave exactly like they would if you just press those on the keyboard of your computer. And the reason that this works, the reason it works with the Makey Makey, what's happening mechanically, is that each key on your keyboard is a switch. Think of it like a light switch. When you flip the switch, electricity can run through it and it sends a signal. The difference between the keys on your keyboard and the switches, the light switches that we have in our house, I've got one behind me, can I point at it on the camera? Yeah. The difference between those is that the keys on your keyboard are what is called a momentary switch, and that's because they are only active for the moment that you are pressing them. So imagine if the light switch on your wall was spring-loaded, so that every time you turned it on, as soon as you let go, it turned itself back off. That's what the keys on our computer keyboard do. They only send an electronic signal through while you're pressing down on them, so that's called a momentary switch. But it's still just a switch. It just lets electricity through. Here's an example of what that actually looks like. I say actually, it's a drawing, but a sort of diagram of how that works. So you've got electricity that will move from the power source, here a battery, and it will try to move into the light bulb and do some work. All electricity, whenever we're utilizing, it's just doing some work. And here it's just lighting up a light. So the electricity wants to move from the battery into the light bulb and then back to the power source. And that's what happens in our computer as well. A lot of other stuff happens along the way. That's the work that we're talking about. But this is the basic idea. Now, with that switch introduced, the electricity can't move through if the switch is not flipped, if the connection is not made. Essentially, a switch is just like a moat. It's like breaking the connection of that wire. And if the switch is open and the electricity can't move through, then nothing's going to happen. And so whenever you flip that switch or press a button on your computer, what you're doing is you're closing that, you're bridging that connection, and that electricity is able to move through that loop and do some work, and we're able to see things happen. Well, the Makey Makey works in the exact same way. When I connect an alligator clip to the earth pad, and then I connect another alligator clip to one of the buttons, the electricity wants to go from one to the other, but no work is going to happen until that connection is bridged. So if I connect a banana to my space key, and I connect myself to earth by holding onto an alligator clip, then the electricity is only going to pass through and close that loop when my hand touches the banana, at which point the electricity goes from the Makey Makey into me, into the banana, back into the Makey Makey, and into the computer. You can see that here in the image. So you can see that that yellow alligator clip is connected to our space key, and then the other end of it is connected to the brass fastener, little push fastener, which is touching the paper clip. So that paper clip is bent, and so it is springy. Whenever that paperclip is up, the electricity cannot move through to the other side. But when we press down on it, it bridges that connection, it closes that gap, and the electricity is able to move through just like that light switch diagram that we saw, just like the keys on our keyboard. And when that electricity moves through, it presses the space key. So we were able to build a momentary switch, just like the ones on our computer keyboard, with a Makey Makey and materials as simple as push fasteners and paper clips. So that's kind of what the Makey Makey is, but what is the Makey Makey used for? We use it for a ton of different invention projects. We think it's a great way to get kids hands-on and problem solving in the real world. I love for kids to learn coding. I love for kids to learn computer science and to learn how to do things with computers. You know, they're like the most amazing, powerful tools that we've ever made. But I also think it's important for kids to get hands-on and work on things in the real world, sometimes away from their screens. And we think the Makey Makey is a perfect invention tool to promote that. And it can be used in all sorts of different fun ways in the classroom. The ways that we talk about a lot are these quiz show buzzers, like what you see in the animated GIF there. So students can build buzzers, and when they slap those buzzers, it allows them to buzz in. We have an app that's just a really simple quiz show buzzer app. But before we made that app, we would use Scratch, and we would tell people, yeah, just build a little quiz show buzzer in Scratch. And whenever they slap that, they can buzz in and answer questions while they're studying for a test. And kids really like doing that. And if you want to get kids excited about studying for a test, letting them build their own buzzers and turning it into a game show is a great way to do it. We also promote a lot of sort of like cross-curricular work and a lot of cross-discipline work. So taking the posters that students are building, or the dioramas that they are making, or the different projects that they're creating to illustrate their knowledge of a subject, be it social studies or math or science or literature. If they make a poster to illustrate their knowledge of a subject, they can then take those same little brass fasteners that we saw in my paperclip switch. They can punch those through the poster, connect an alligator clip to the back of it, and make their poster talk or make their poster play sounds. So that whenever someone is walking down the hall, if you've got a poster with a little table beneath it with a Makey Makey on it, they can touch that poster at different points and it'll trigger button presses, and they can hear the student explain the topic that they were studying, or they can see animation on the computer screen. They can wake that poster up, basically like a museum exhibit, or even like do that again with dioramas where you tap on different parts of the room that you've built or the landscape that you've built, and you can hear the students explain that. So that's a really, really cool, fun way to get them engaged in hands-on making that is relevant to the things that they're learning in the classroom, and to build physical things that they can then connect to the computer work that they're doing as well. And then my personal favorite, because I grew up on video games and I wanted to be a video game designer when I was a little kid, is they can build their own game controllers. And this was really what made me fall in love with using Makey Makey and Scratch together over a decade ago, was the ability to program my own games and then build the controllers that I use to play those games. This screenshot here of the Play-Doh controller that you're seeing, that's actually from the original Makey Makey Kickstarter video when the founders and creators of the Makey Makey were college students. They built Nintendo controllers out of Play-Doh and played Mario with it. And the second I saw that, I fell in love. I thought that was fantastic. And I cannot tell you how many paper controllers or Play-Doh controllers or cardboard controllers I have built for playing my own Scratch games since then. And kids get really excited about doing that too. I've done lots of projects in school classrooms where kids design their own games, and then they design arcade cabinets and controllers for those games and set up their own classroom arcade where everyone can try each other's stuff. And a lot of the times it's really fun because those games will be about subjects that they've been learning about. They'll build games about traveling to space, or they'll build games that are set in periods of ancient history, or games that are adaptations of stories that they've read, and then they'll all play each other's games. And it is super cool and super fun to see them do that. Other things that it gets used for quite a lot, we are known for the banana piano. So naturally, the Makey Makey gets used for musical instruments. It's so fun and easy to build your own musical instrument out of recycled material that you find around the classroom, and then hook that up to Scratch and have it make different sounds. We have some music making apps for younger kids who aren't like coding age yet. But my favorite is when the kids are in Scratch and they're figuring out how to control the sounds themselves and make them, and then building instruments. I actually have on my desk here, this is a bongo drum that a student made. And so these are conductive touchpads. So he would clip the alligator clips onto these, and then he would play the bongos and control the sound of those bongos on the computer So that gets done a whole lot, and we love that. Like I said, dioramas, if a student is studying a specific space or an environment or a landscape, building those things out and making it so that you can touch the different parts of them and learn about them is really cool. And then another fantastic area that I always try to point out is accessibility. I think that the accessibility stuff that can be done between Scratch and Makey Makey is fantastic. So you can see here a demo that one of my colleagues made where every time you tap on a word that was written with conductive pencil, it bridges the gap, it presses the button, and you can see that word being spoken in sign language. And so it's a great way to build learning tools or accessibility tools to be used in the classroom. We actually see a ton of different applications for that that are always really, really cool and exciting. So that is the Makey Makey all by itself. But if you're not using our apps, or if you're not using, a PowerPoint slideshow or something with this, what are you using? What are you controlling with your Makey Makey? The Makey Makey is a great input, but what are you going to have it control? And like I said, truly my favorite thing is to have it work with Scratch. So let's talk about how we can combine those two things together. Using the Makey Makey with Scratch is almost as easy as using Scratch by itself, and that's because they just automatically work together. So once you know how to use the Makey Makey, adding it to your Scratch projects is as simple as making sure that your when key press block is used, you're just using the same one as on your Makey Makey touchpad. So in the example here, you can see that I have when the up arrow key is pressed, set the pitch to a certain, set the pitch effect to 0, and then play a guitar sound until it's done. So all I would need to do to use the Makey Makey with that block, I wouldn't have to do anything special other than plug the Makey Makey in and touch the up arrow here. It's the same as touching the up arrow on my computer, except I'm doing it on the Makey Makey, but every time I did this, that code would run. There's no extra work that needs to be done. There's nothing additional that you need to add to it. They just work together, which I think is fantastic. You just have to know how each of these things work independently and then put them together. There is an extension for the Makey Makey in Scratch. Well, if they already work together perfectly, why do we need an extension? You don't. You don't need the extension, but it is helpful for beginners. So this extension limits the button press options that you have inside of your dropdown in Scratch. So I'm going to go back a slide. When I use this yellow block that says when the up arrow key is pressed, if I press the little down arrow caret thing on that and want to choose something other than the up arrow, then I have a ton of options. I have up, down, left, right. I have space. I have W or A, B, C, D, E, F, G. I have W, A, S, T. I have every key in the alphabet. Well, we don't have all of those on the Makey Makey. On the Makey Makey, like I said, we have up, down, left, right, space, click, and then on the back you can actually plug into W, A, S, D, F, and G, or you can do the left mouse click or the right mouse click. So we have a lot, but we don't have as many. And if you're working with really, really young kids who are brand new to these things, it can be very helpful to add this extension so that the only button presses they can choose are the ones that are available to them on the Makey Makey. They'll never accidentally say when the Z key is pressed. We don't have a Z key on the Makey Makey. So this will just limit them to the stuff that is there to make sure that they don't accidentally select something that they can't use. It's the exact same as using Scratch otherwise. There's nothing else additional that you need to know. It just puts some guardrails up to make it a little bit simpler, but either one of those is going to work exactly the same otherwise, which I think is really great. Okay, so that's how we use the two of them together. What do we do with Scratch and Makey Makey together? So the example that I gave earlier that is my personal favorite is cardboard arcades. We can add physical enclosures for the games and the projects that students make. We can just grab some cardboard. Like you can see here, they just cut a hole in a cardboard box, and then you can see on the surface of that sheet of cardboard, they've got some buttons that they've made. It looks like they probably made those out of aluminum foil, and they've glued that onto the cardboard. And then you just tap on those, and it works. What's fun about this is that it kind of recontextualizes the game. It doesn't just feel like a Scratch game running in the browser. It feels more like a full game. They can decorate the sides of the box. They can customize the controller. Maybe you have it so that whenever you press the space key, your character jumps. You could make a button that looks like your character jumping, and every time they hit that, it jumps. And so even if someone didn't read or didn't know the rules or didn't know that it was the space key, they would just see, maybe you've got like a Mario type character, a little jump man, and every time you slap on that, the character jumps, they would intuit and know that that's how that works. so you can customize the game controls that you're building. You can also get weird and creative with how you press buttons. It doesn't just have to be a touch, right? There are all sorts of different switches that you can build using found materials around the classroom. And this gets into really great physical engineering and making and construction challenges for the students. So my favorite one of these is you can see the aluminum foil ball on that middle image. There's an aluminum foil ball and it's inside of like a little container. And that's basically like a tilt switch. Every time we tilt that left or right, when the ball rolls all the way to the left and hits the edge, that would trigger a key press. And then when you tilt it the other way and it rolls all the way to the right, that would trigger a key press. And so now you could make a tilt switch and you could build like a balance game or a game where like a character is flying and they're looking forward and you fly them by tilting them left or right. You can find all sorts of different really interesting ways. One of my favorite things that I ever saw was a kid built a game that the entire scratch screen looked like kind of like the window if you were sitting in like the Millennium Falcon or something. It was like you're looking out of a spaceship. And he built cardboard spaceship controls so that when you sat down, it was like you were in the cockpit of a spaceship and you were flying. And all of the different controls, they didn't feel like video game controls. They felt like a cockpit. And so you can get really, really inventive with the things that you are building. And this will take kids from all different areas of interest and pull them together to make things. This last one is something that I think is really fascinating, is the idea of building screen-free Scratch projects. Because we can add invention and a physical element to the work that we're doing, you can build totally different interfaces and totally different systems that don't rely on the traditional sort of video game screen. So what you see in that last picture there is a ball maze, and every time that little aluminum foil ball rolls through, if it passes over two pieces of foil that are really, really close to each other, then it'll bridge the gap between them and it will register as a key press. So every time you tilt that maze around, if the ball rolls through a certain area, it'll trigger a key press. And what you can do with that then is you can build timers so that you have students race to see, can they finish the ball maze before the time runs out? And suddenly you have an entire game that can interact or be interacted with without using the screen at all. You can make a button press that starts it, and then you start tilting it. The example of this bongo right here, I could set this bongo up and I could literally like close my computer monitor and kids would play the bongos and the sound would come out of the speakers. Kids do that with guitars and pianos. So you can build all sorts of projects that are screen-free but still utilize the coding that the kids are developing and learning in Scratch, which I think is incredible. It totally like changes and recontextualizes what you're able to do, which I think is really, really cool. I want to take a moment to kind of, since we've talked a lot about this, to look at all of this and see what it looks like. So I'm going to switch over to my Scratch window real quick. So now we are in Scratch. So let's actually see a demo of this. Let's see. I'm gonna attempt a live demo. So I'm going to switch my camera as well. Okay, and I can see that we're seeing my screen here, and we've got my Makey Makey, and I've got a drawing that I did. I'm going to test this drawing as a Scratch project. So the way that this works is pencils have graphite in them, and graphite is conductive. And so I should be able to then use this drawing as a controller. I need to make something happen in Scratch to do that. So let's grab, I'm going to demo both of the different kinds of blocks that I talked about. I'm going to grab a regular when key is pressed block, but I'm also going to add that Makey Makey extension just so we can see both of them. So I'm going to say when the left arrow is pressed on the regular one, and I will say when the right arrow is pressed on my Makey Makey one. And I'm going to do this pretty simply, so I'm just going to grab the move blank steps. And on my left arrow, he's going to need to move -10, isn't he? So let's test that with our computer keyboard. And I can see that when I press left, he moves left. When I press right, moves right. And I can test that on my Makey Makey. So what I want to do here is I want to make sure that I am grounded. So I'm going to press Earth. And now when I press the left key on my Makey Makey, I can see that the cat moves to the left. And when I press the right, the cat moves to the right, just like with the keyboard. So now I want to grab some alligator clips. I'm going to put one on the left key here. And I'm going to connect that to my drawing. It's possible that this won't work because this drawing, I've been traveling around with it when I do demos and stuff. And it's possible that I've rubbed the graphite off and I'll have to do some work. I'll have to take my pencil out and redraw, but let's find out. Connect that there. This is the one I'm more worried about because it's a longer connection and there's more room for it to break. And then the last thing that I need to do is, in order to close this circuit, if I touch it right now, definitely nothing's going to happen. And that's because I'm not connected to this loop. So the last thing I need to do is I need to connect myself to one of these. So I'm going to grab my gray wire and hook that up to ground. And let's see, I'm just going to hold on to that with my left hand. So I'm holding that with my left hand. I know that when I touch the alligator clips themselves, my cat's going to move. But let's see if that circuit actually extends into my pencil drawing. So it does on the left. So now whenever I press left, he moves to the left. But what about when I press right? Yeah, see, this one's not working because it's broken. And so that means that I need to add some more conductivity. I need a better, thicker graphite path for this to move through. So I'm going to lay down some more graphite. I'm basically building a wire. And now let's test that right arrow. Hey, look at that, it works. So really quickly, I have prototyped a controller for a game. The next thing that I could do is I could build buttons for this so that instead of tapping on graphite, which gets my finger all smudgy, I could tap on something else. So let's do that really quick. Instead of using this paper controller, I can use any conductive material, and I'm going to use Play-Doh. So you've got a blue Play-Doh there for my left arrow, and a pink Play-Doh here for my right arrow. I'm going to ground myself again by touching earth. So I'm going to grab my gray wire to do that. So now I'm grounded, and I should be able to, let's back that cat up. Come back here, cat. And I could build buttons out of Play-Doh for up, down, left, right. I could do, I've got an A and B button here, but I would wire those up to like the space key and maybe the W key or something else there. So we can start as simple as this. We can start with the simplest little button presses and then build really elaborate, complex controllers if we want to. All the way up to, one of the controllers I have here is actually, look at this, a full joystick that we made out of the Makey Makey box using just hardware from the hardware store. And whenever I touch this joystick, if I plug this one in, I'll go ahead and plug this one in. So I'll plug in this Makey Makey that's got all of these wires on it. And I should be able to use my joystick to move left and right. So we can start with something as simple as a drawing or Play-Doh or cardboard or paper clips. And we can go all the way up to prototyping real controllers that behave exactly like they would, you know, on a game console that you purchased from the store. It's a great way to get kids excited about doing hands-on work. It's a new way to get them thinking about problem solving and kind of getting an engineering mind going. They can design things based on their interest and get excited about them, and then they can connect it to the stuff that they're building in Scratch on the screen, which I absolutely love. So now I'm going to switch back to my other camera. Let's see if I can do that. Hello, I'm back. And I am going to switch back to our slides here. And now that you know what the Makey Makey is, you know how it works, you've seen it in action with the Scratch program, let's talk a little bit about going further. What else can we do beyond those basic key presses? And what I want to do here basically is give you an update on some things that if you already knew about the Makey Makey, you might not have seen yet. Or if you're brand new to the Makey Makey, you've definitely not seen yet. Just some things that we can add to this that take it even further that I think are really exciting. And the two updates that I have for you are our backpack bundle and what we call our Coda Key backpack. These are things where if you are seeing what I'm doing here and you think this is really exciting and you say, I want my kids to be able to build and invent ways to interact with their Scratch games. I want to be able to take the learning that they're doing beyond just software. These are things that either make it easier to do or they kind of enrich and deepen that process. And the first one of those is our backpack bundle. Do I have my backpacks here with me? I do. Let me grab my backpacks. So the backpack bundle is a set of 3 accessories that we made that make it easier to do stuff that the Makey Makey can already do, but it just makes it easier and faster. And I'll show that off for you on my main camera here. I'm going to unplug all those wires from my Makey Makey it's currently hooked up to Play-Doh. So I've got my regular Makey Makey here, but what I want to do is I want to press more buttons than just the up, down, left, right, space, and click. Now I mentioned that hiding on the back of the Makey Makey are these pins, these jumpers, that I can plug wires into, and now I can do W, A, S, D, F, and G, which is great for like a two-player game, and I can control my mouse movement, up, down, left, right, and the left click and the right click. But these don't use the alligator clips. These use just regular wire. And especially if you're working with like younger kids who are just starting out, the dexterity is not always there, right? The manual fine motor skill dexterity to plug in wires and then connect them to your physical projects. They're great for older kids and they're great for advanced projects, but especially for younger kids, they can be difficult. And if you're working with elementary age kids, we know that they get pretty fidgety and wiggly. If they're building a big project and kids are running around and stuff, the wires just come unhooked a little bit easier than the alligator clips do. We wanted to offer the ability to do more stuff, so those pins are on the back, but they're just not going to be as fast or as easy to use as what's on the front. Well, the backpack bundle kind of solves that. It says, hey, do you know that your kids are going to want to build two-player games, or they're going to want to use as many buttons as they can, and they're too squirmy, or they're building big projects where they get up and move around, and they're just gonna, there's a chance those wires are gonna come out. That's kind of what we've done here, is these backpacks, this is the two-player backpack. This connects to the back of the Makey Makey, and it plugs into those pins exactly like a wire would. So I'm gonna plug in this two-player backpack, and now on the front of my Makey Makey, I have up, down, left, right, space, and click. And on the back of my Makey Makey, I have W, A, S, D, F, and G. Did I get those in the right order? Yes, W, A, S, D, F, and G. And kids know that that's up, down, left, and right because it's in all the games that they play already. If you've got kids who play like Minecraft and stuff. So now they can do a two-player game on the Makey Makey with alligator clips for both players, never having to use smaller wires. So that makes it just easier for them to do more faster. And you know that the projects are going to stay together. If they trip over a wire or something, those alligator clips are going to hold it in tight. Let's say you have kids who want to build a piano and they don't want to just use up, down, left, right, space, and click. They don't just want 6 buttons. They want as many keys on the piano as they can get. Well, the next one that we have is the Makey Max. This gives you all of the pins that are on the back, the W, A, S, D, F, and G, and the mouse controls. It gives you all of them at once. You can connect all of that together and get more access to absolutely everything. So it basically just takes the back of the Makey Makey and makes it alligator clip friendly. It doesn't have the visuals, the up, down, left, and right. So for like some projects that kids are doing, if they're building games, this is not as clear for them visually. But if you've got kids who aren't building a standard video game controller with a D-pad, this is a great way to just add a ton of buttons. And then the other one that we have, and this gets used in very different projects, is the Makey Mouse Backpack. And the Makey Mouse Backpack is for moving your mouse cursor up, down, left, and right, or clicking the mouse keys. So not used in the very traditional sort of like Mario type games or games where characters are like walking around on the screen. But if you have a game where the main interaction is by moving the mouse, you can do that with this, and you can build mouse controls for it and just plug that in. And now you have like full mouse controls on your Makey Makey, which is a really different way of doing things, but in the right circumstance is a great tool to have. So those basically make it easier to do the stuff that you could already do on the back of the Makey Makey, just using alligator clips instead of jumper pins. So those are that is the backpack bundle. They come in a set of 3. You snap them on the back of any Makey Makey that you buy today, and they just work exactly like you would expect the mouse and the keyboard to work. The other backpack adds new functionality, and this gets really weird and exciting. So if you've used a microbit at all, and I know that there's a microbit extension in Scratch, but if you've used a microbit at all, you know how powerful this is. This is a microcontroller that allows you to access tons of sensors. So it has a light sensor where if you turn the lights in a classroom on or off, it will know. It has a sound sensor where if the sound gets too loud or too quiet, it will know. It has tilt sensors left and right, up and down. It has temperature sensors. It has an accelerometer, all sorts of cool sensors and interactions. And what we can do now with the Kodaki backpack is we can plug that into a Makey Makey. So I take this backpack and I put a microbit on it, and then I plug that into my Makey Makey. And now I can write code for the microbit that tells it to press buttons on the Makey Makey for me. What I can then do is I can say, whenever I clap my hands, if the microbit hears a really loud sound, press the W key on the keyboard. And now I've basically built like a Flappy Bird game where my character only jumps whenever I clap my hands. And that's usually one of the very early projects I do with kids to demo this, and they get really excited because they're all in the classroom like clapping, and their characters are, it's very hard to do, so the characters are losing and they're all frantic and chaotic. But it gets them really excited about finding new ways to code, and that's what we want. Is we want new ways of interacting that get them excited about it. You can make tilt controllers where when I tilt it to the left, it presses the W key, and when or the A key, I guess it is. And when I tilt to the right, it presses the D key. And now I can move my character left and right by tilting. We've made a theremin out of a phone LED. You turn the flashlight on your phone, and as you get closer and further away, depending on how bright the light is, it plays different notes. So we can just build all sorts of interactions for Scratch using the Makey Makey and the microbit that we wouldn't have been able to do before. And it just opens up all new doors that are really interesting and allow us to code all sorts of new crazy stuff. I think that these are really cool, exciting tools for students who are more advanced. Maybe you have a Scratch classroom that they've done all of the basics. You've got the kids kind of where you want them to be in code, and you say, like, how can I encourage them to continue problem solving and to continue engineering and thinking of new ways to solve problems and do things that they want to do. You know, how can I invent new challenges for them that cause them to think further or go deeper on things? And that is like such a cool tool to do that with. We have built so many fun demos with it. And anytime I go into a classroom and give it to the kids, they all start experimenting and saying, oh, well, if it can do this, you know, can I make my character do this? Or can I make it where, you know, they like to make it where when the lights turn out in the classroom, the lights turn out in their game and their character says who turned up the lights or something like that. And they just get excited about experimenting and seeing the real world interact with their game in new ways. There's a demo that we saw where someone, they made it so that whenever the temperature in the room got to a certain point, so if they had a fan on, the room would get colder, or like the window would open or something, and the characters would react. And they love seeing those interactions of the real world with their game. And this makes it super easy to do that. You can technically already do some of that with the microbit, but basically this just makes it way easier to pull those microbit interactions into the things that you're doing in Scratch. And it also opens up possibilities that you couldn't do just with one or the other. So we really, really love that. Really quickly, I want to show you a couple more examples of what we can do. So I'm going to jump back over into Scratch, and I also want to show you different types of buttons that we can create. So one of my favorite things to create, I'm going to switch my camera back to my desk cam. If you're just starting out with kids and you want them to understand this stuff, something that's really fun to create, this is a conductivity tester. So this is a fancy conductivity tester that I made, or I didn't make this, one of my coworkers made this, but that we made with a Cricut. And so what you have here, these are just, this is just conductive foil, and it's an adhesive foil. So we can cut it on the Cricut and then stick it to paper like a sticker. And then I can, let's see if these have too much Play-Doh on them. And then I can connect that to a Makey Makey. And I want to know whether or not something is conductive. So I'm going to hook up my Makey Makey to Earth and the space key. So I've got that hooked up to Earth and space. And now whenever something bridges that gap, it should, you can see the light going off there on my Makey Makey. So I'm going to make my Scratch cat let me know that something is conductive. So now I'm going to say, whenever my space key is pressed, and I'm just going to have my Scratch cat say, that is conductive. Oh, it would help if I could spell. Conductive. Let's test it. So now I am conductive. So if I bridge this, and this is like a great first project to do with kids so that they can really understand what it is that they're doing. I built that with 2 pieces of code and 2 strips of foil. So yours doesn't even have to look as fancy as mine, but you can do that really quickly. And then they can go around the classroom and they can start grabbing different things and testing whether or not those things are conductive. So if I take my Play-Doh again and I say, well, is Play-Doh conductive? And I lay it across there, my Scratch Cat tells me, yep, Play-Doh is conductive. And I can take one of my paper clips and I can say, is my paper clip conductive? And the Scratch Cat will tell me my paper clip is conductive. So I just want to show you and make sure that you see how easy it is to get started building things in Scratch and real hardware that allow you to do all sorts of stuff. Once the kids understand this basic idea of like, you just need 2 pieces of conductive material that touch each other, and you just need a Scratch code that reacts to that, they can start building more advanced stuff. You know, here's a button that I built. I'll take these old wires off of my buttons and I'll show you what the inside of it looks like. This is a button that I built out of 2 pieces of canvas board, but we can build these out of cardboard, out of the recycling bin as well. And all I did is I took 2 pieces of conductive material and I laid them across it, one going this way and one going that way. And we can just really, really quickly put stuff together to build a button. And we can go from nothing to a reaction really simply. I'm going to make this cat do something a little bit more interesting, right? Let's make it so that he jumps. So I'm just going to say change Y, and I'm going to do I'm going to say repeat, change Y, and then we'll duplicate that again and have him change by -10. Let's drag him back down to the bottom. So now whenever I press my button, so I've built a jump button. So Makey Makey jump button, and when I press it, my cat jumps. So you can get kids started inventing with as little as some recyclable material, some foil, and Scratch in seconds. And we can go from that all the way up to having them build complex controllers that tilt or that listen to sound or react when you shake them. They can build arcade cabinets, cockpits, interactive posters, just the whole world, literally, like physically, the world outside becomes a controller for your Scratch games really quickly and really easily. And we are excited to share that with you and to see what people make with it. So thank you all for coming and listening to that. If you have any questions, I am going to stick around. We've got a little bit of time left, and I will answer any questions that you have. I'm going to switch back over to my main camera. Cool. So if we have any questions, we've got time for those, and I can either put some demo. If you've got questions about the hardware, I can hook it up and demo things for you. I can show you how you might build things in Scratch, or just questions about how we would implement it in a classroom. Like I said, I've been in and out of classrooms doing this for, gosh, about like 10, 11 years now. So I'm totally excited whenever people have questions or have ideas about how to use it in the classroom. I'm happy to talk about those. Okay, so got a great question from Andrea here. Is that a special kind of foil? If so, what? The answer to that is like yes and no. What you saw on my stop switch that I made is a sticky foil. It's just foil with it's foil tape, and so in that way it is special. Is that what makes it conductive? No. I can go get aluminum foil out of my kitchen drawer and that will work. I can chew a piece of like double mint gum and take the foil wrapper and use that, and that will work. I can peel the top off of an applesauce container and that will work. Any type of foil is going to work as in the exact same. Now, one interesting caveat there is that this foil tape that I've used on this one, this is like really cheap foil tape that you can get on Amazon, and it works great, but it breaks easily. And also the adhesive on the back of it is an insulator. So if I laid another piece of foil tape across this one, and I wanted to have it so that whenever I touched one, it connected to the other, it wouldn't work. The adhesive between them insulates them and keeps them, it puts like a binder layer or a layer between them that blocks that connection. And so we actually at Makey Makey have a foil tape that we use, and the adhesive on it is conductive. And so even if I lay one piece of foil tape on top of another, it's going to work. So you do have to test when you're using foil tape to see what's going to work in what ways. But pretty much all foil and any metal is going to work. I was talking to my coworker the other day, and he pointed out that our MacBooks are actually grounded. So if I tap on the side of my MacBook and then tap, that will work as well. Two other questions from Ayush. Where are these sold? So we sell them on makeymakey.com. We also sell through Amazon. We have a lot of distributors and resellers that we work with throughout the US. If your school can't buy directly from us for some reason, we've been around a long time and we work with pretty much everyone. So there are a lot of distributors that we can get you connected with if for some reason you can't buy directly from us. So that's a good question. And is the Player 2 sold separately from the bundle? It isn't. Right now, the only way to get the backpacks is inside of the backpack bundle. And that's because what we found is it's hard to know who's going to want which one, and breaking them out like that, it kind of makes it more difficult to manage those. So right now they're all in the bundle together. Mar says, do you think the Makey Makey extension on Scratch is one reason why people might have the misconception that special software is required to use it? Would only using the regular key blocks make it more clear that it's just pressing the normal keys? That's a great question. My intuition on that is no, because my intuition is that most people don't really discover that extension until after they've gotten a Makey Makey. And I could be wrong about that, but my intuition is that you kind of ignore the extension if you don't have one yet. And when you get the Makey Makey and you start using it, I think most people, we do a pretty good job of holding beginners' hands in our guides and in our resources, and explaining anything that works with a keyboard is just going to work with a Makey Makey. We also have a ton of tutorials on Instructables and on our website and on YouTube, some of which predate that extension. And so we actually have tutorials on how to use the Makey Makey with Scratch, where we don't even mention the Scratch extension. So I think it's really possible that there are people who get confused about that. And that would not surprise me, but I think broadly the audience discovers the extension afterwards. And actually, I've had people ask me, like, what's the extension for? What does it do that I can't do normally? And I go, nothing. It just makes it a little bit easier with young kids. That's a great question. Let me see. Heather asks, what is the name of the foil tape you use, please? So if you just search on Amazon, the cheap stuff is just copper tape. And if you want to get ours, it might be just called conductive fabric tape. Or if you rather than searching for foil tape or for copper tape, don't use those words. Just search for conductive tape, and that's how you'll find this. We also sell this in booster kits and bundles on our website as well. So you can buy this tape directly from us, and you will get not just the kind that we use, but the exact one that we use in all of our projects as well. Jason says, I love the idea of creating scientific measurement tools and experiments with the Makey Makey. One activity I saw on the Makey Makey site was a ramp that had connectors at the top and bottom to measure the speed of a Matchbox car. So cool. Do you have any other ideas for science integration? Yes, we also have a tutorial on like measurements where you take a measuring cup and you put foil tape, or you put the conductive tape on the inside of the cup at different levels. And as you fill it up with material, you trigger different key presses. And then you can say in Scratch, when this button is pressed, say, 1/4 of a cup, or say like 1 milliliter. And then when you get this point, say 2 milliliters, whatever. And so you can do that. But then I've seen people take that and like take ice and let ice melt and see how long it takes in a room of a specific temperature for the ice to fill up and hit certain points. And they will record every time it hits a new one of the buttons. And so you can do a lot of different measurement stuff with it that way. My favorite little fact is that if ice gets cold enough, it's not conductive. And so you could have 2 Makey Makey alligator clips in a cup of water, and you could put it in the freezer with the wires running out. And you can see how long it takes for it to reach a point that the molecules, like the frozen molecules, are no longer conductive. So you can do some really interesting stuff. And then also just the idea of like what is and isn't conductive, and why are things conductive and not. You can build different guides that way. Stephanie asks, where is this tutorial, please? I am assuming you were talking about the one for the measuring cup. All of our lessons and content and resources are on makeymakey.com. So if you go to makeymakey.com, on the tops of the website, there's a resources, or there's a menu, and one of the things says resources. And if you click on resources, you get a drop down that says different types of activities. And if you go to all activities, it will show you all of our different ones. And the measuring cup one is in there. You can also search our website for that. we have a drop down on the resources page as well where you can choose different types of activities. So I believe you can select like a science activity from that and pull it up that way. But if you're scrolling through that menu and you're just not finding it, the search is pretty well built. And so I think if you literally search for the word measuring cup, you should be able to find that tutorial. Yeah, that's a great question as well. Awesome. I think we're getting pretty quiet in the chat, which means that we might have answered all of those. We love helping people get started with this stuff. So if you have more questions, if you think, oh, I might want to use this in my class, but I'm not sure about X, Y, or Z, please reach out to us, support@joylabs.com, or find us on makeymakey.com. And we are always happy to answer questions and help get you started. I especially love answering questions about connecting it with Scratch, and any resources that we have. If you shoot us an email, I can send you links to the things that you're looking for as well. So we're excited to do that. So if there are no other questions there, thank you all very much. I loved having you here, and we'll also be back later in the day for the other, like the meet and greet type thing. So I'll be here for that too, so we can talk more then as well.